Good morning. Good afternoon, students. In the last class, we discussed about the one of the main feature of the surface chemistry, that is adsorption. So in the today's class, we are going to discuss with the another feature of the surface chemistry, that is catalysis. Okay? Catalysis. Understand? So students, listen. In this catalysis, we have to study what is the catalysis process, what are catalysts, types of catalysis, okay, and their activity and their selectivity. Okay. So what we are going to discuss here, catalyst and type, catalysis and type. Okay, their activity and selectivity. These are the topics we are going to cover in this catalysis concept. So students, first one, what is catalyst? Okay, that is very important. So catalyst is a chemical compound or a chemical species which alters the rate of a reaction. Without undergoing any chemical change at the end. This is not catalyst. Catalyst is a chemical species which alters the rate of a reaction. Either it increases the rate of a reaction, and it retains at the end of the reaction. Means the catalyst is regenerated. It only alters the rate of the reaction, but it is not involved in the chemical reaction. Okay. So in this catalyst, two types is there. Before going with that, so before I will explain the characteristics of the catalyst. Later I will explain types. Characteristics of catalyst. Okay. What are the characteristics? So the first one is, students. So the catalyst remains unchanged at the end of the reaction. Catalyst remains unchanged at the end of the reaction. Next, catalyst cannot initiate the reaction. Okay, next, they cannot shift equilibrium. Okay, they cannot shift equilibrium. Next, catalysts are specific in their action. They cannot shift equilibrium. They are specific in action, and they needed in small quantity. Okay. The catalyst action is maximum at a particular temperature. called optimum temperature. Understand? So these are the characteristics of the catalyst. What is the characteristics here? Listen, the catalyst remains unchanged. Means if any, for example, I say if this nitrogen is there, this hydrogen is there, here iron is taken as a catalyst. This iron cannot change its property, iron remains iron only, but it helps to form NH3 easily. This helps to form NH3 easily. Understand? So this is what the catalysts do. So this remains unchanged at the end of the reaction. And you know, in the what is the preparation or a conversion of ethanol to ethene to ethanol, I said acid catalyzed. Acid catalyzed means acid is H2SO4. It is dissociated as H plus and HSO4 minus. Okay, after step 1, step 2 and step 3, the step 3 is removal of proton step. Correct? When this proton is removed, again it combines with this HSO4 minus to form H2SO4. So open the alcohols, phenols and ethers chapter. Okay, in that you just follow the mechanism I explained. Conversion of ethanol to ethene and ethene to ethanol. In that initially, those two are acid catalyzed. Means that acid is used as a catalyst. It produces proton. That proton is involved in the reaction. But at the end of the reaction, at third step, okay, that proton is regenerated. That proton combines with this HSO4 minus again, and acid is regenerated. That is what catalyst. At the end of the reaction, it remains unchanged. Next, catalysts cannot initiate the reaction. They cannot start the reaction. But once the reaction is started, then they have the capacity to accelerate the reaction. For example, if any A reacts with A reacts with B to form C. If the reaction taking place 20 minutes to complete without any catalyst means, if we use some catalyst, it will complete it within 10 minutes only. Okay, the reaction happens with catalyst or without catalyst. But what is the role of the catalyst means? If the reaction starts, then only it increases the rate of the reaction. It fasters the rate. It fasters the completion of the reaction. Understand? Next, they cannot shift equilibrium. For example, if any reaction is there, that is the equilibrium reaction assumed. So I'll take this CH3, COO, CH3 is there. To this HO is added. Hydrolysis in the presence of HCl. So students, this is a reversible reaction. Equilibrium is like this. Then it forms CH3. I take this one. CH3, COOH dissociates and associates. CH3, CO minus plus H plus. So students, equilibrium is like this. Means it is a forward reaction, favors rather than the backward reaction. Okay. So if we use any catalyst here, any acid or anything to break this, here there is no need of any catalyst, but I am telling just to you. If catalyst is used here, then here the equilibrium symbol is there. This catalyst cannot shift this equilibrium. If it is a forward reaction, it cannot help to do backward reaction. The equilibrium remains same even the catalyst is used or not. Even in the presence or absence of a catalyst, equilibrium remains same. So the next one is catalysts are specific in action. Means if the catalysts are used to prepare, for example, this alkene is there, CH triple bond CH. Then here the catalyst is used to prepare alkene means Alkane means it prepare alkane only. If the catalyst are used to prepare alkene means they prepare alkene only. Are you getting? They are specific in their nature. If catalyst is used to prepare particularly alkane, then they prepare alkane only by increasing the reaction. If they are added to prepare alkene, then they used to prepare alkene only. So they do their specific action. They won't change their action. So they are specific in their action. Next, the needed in a small quantity because small quantity is enough. For example, any 1 liter of solution is there, then 1 liter of what is that? I hope you did the experiment. What is that? KML process, FA solution. Later you will do in the laboratory. Okay. In that, acid is the catalyst. Acidic medium we wanted. That acts as a catalyst to increase and to maintain that. What is that? Redox reaction. So students, there we are going to use only 2 to 3 drops of concentrated acid. 2 to 3 drops of concentrated acid. And most of the salt analysis you may see, you are going to add only 2 to 3 drops of acids. Understand? So only small quantity they need. 1 liter of a solution is there, 1 liter of a solute is there. If they want to mix with each other, we have to use catalyst. A pinch of catalyst is enough. Understand? They required a small quantity. Next, the catalyst action is maximum at a particular temperature or optimum temperature. For example, I told you this nitrogen combined with this oxygen means it requires a temperature. So, either as a catalyst, it requires a temperature of 700 Kelvin. So, this is called optimum temperature where that catalyst shows the maximum rate in the increase in the rate of a reaction. Okay, that is called optimum temperature. These are the characteristics. Gunagalu, Lakshanalu. What is catalyst? What is their action? Okay, this is the characteristics of catalyst. Next, we will study types of catalyst. Next one is types of catalyst. Okay, so in that first one is positive catalyst. First one is positive catalyst. So students, what is this positive catalyst means? The catalyst which increases rate of a reaction. The catalyst which increases rate of a reaction is called as positive catalyst. So example for that positive catalyst is, okay, so I'll take this N2 plus 3H2 gives rise to Fe and molybdenum and also 700 Kelvin temperature, 200 atmospheric pressure. So here it forms 2NH3. So students, this iron is a positive catalyst which increases the rate of formation of the ammonia. Okay, that is what? Positive catalyst. Then obviously what is negative catalyst means? The catalyst which decreases rate of a reaction. The catalyst which decreases rate of a reaction means it slows down the product formation. If A and B is there, they react with each other to form product, it decreases the rate of product formation. Understand? So the example for that is, okay, lead tetraethyl in petroleum. Lead tetraethyl in petroleum. It is called as anti-knocking agent. Anti-knocking agent which is used in automobiles. What is the role of lead tetraethyl means? So students, it slows down the combustion of what is that? Petroleum product. Okay, hydrocarbon is there. Petrol nothing but hydrocarbon. It slows down the combustion of that petrol. Means fuel consumption na kadme madutte. Mileage jasti kodutte. By using this lead tetraethyl, it decreases the what is that? Process or level of combustion. It decreases the combustion process of petrol and increases the efficiency. Not efficiency, increases the mileage. Understand? But nowadays this lead nitrate is not used because it causes so much pollution. Because of that reason nowadays it is not used. It causes so much pollution. Understand? So it decreases. Listen, if upon complete combustion only they form CO2. CO2 is harmless, but only small. And the incomplete combustion if happens, it forms carbon monoxide. Instead of carbon dioxide, they form carbon monoxide, CO. You know, so many of you told emission test. That emission test means where they are going to calculate how much carbon dioxide is liberated, how much carbon monoxide is liberated. Means for example, if any automobile is there, the exhaust gas is so much black, too much black in color, exhaust gas. Then obviously it is liberating much amount of CO, carbon monoxide. If it is somewhat white in color, I hope you observe in automobiles, vehicles. Okay, if you start the if the exhaust gas is black in color, the liberation of gas is carbon monoxide. If it is somewhat white in color, comparatively, then it is carbon dioxide. Okay, so this lead tetraethyl decreases the combustion, means of course the production of CO increases rather than CO. That's why it is not used. So this is a negative catalyst. The reaction, which reaction? Combustion reaction. Okay, so the next third one is autocatalyst. Okay, what is autocatalyst? Means the product formed in the reaction, itself acts as catalyst. The product formed in the reaction itself acts as a catalyst. So example for that is hydrolysis of ether. So here CH3 is hydrolysis of ester. CH3, COO, C2H5 is there. So to this water is added in presence of acid. In presence of acid. Listen here, the product formed is no doubt in that it is CH3, COOH and C2H5OH. So students here, the product formed consists of itself an acid CH3, COOH. Correct? So here the catalyst we used is what? Acid only. So in the product again acid is formed, means of course itself is CH3COOH is acts as a catalyst. These reactions are very rare reactions, very less to see. Understand? Autocatalyst means the product formed in the reaction itself acts as a catalyst. The example is hydrolysis of ester. So in this we need any acid as a catalyst, HCl or H2 for anything. Later, the product formed is here. Here is what? Acid only, acetic acid. No matter whether it is a strong acid, whether it is a weak acid, in nature it is an acid. So it is acid means it has the capacity to donate H plus ion. Then obviously this one is also acts as a catalyst here. So this is types of catalyst: positive catalyst, negative catalyst, auto catalyst. What is positive catalyst means? The catalyst which increases the rate of a reaction. Next, negative catalyst means the catalyst which decreases the rate of a reaction. Auto catalyst means the product formed in the reaction itself acts as a catalyst, no matter whether it increases the rate of a reaction or decreases the rate of a reaction. Okay, so this is all about types of catalyst. So another one is there, students. One is the substances which enhances the properties or decreases the properties of catalyst. Okay, so listen, in this another types is also there: catalytic promoter and catalytic poison or inhibitor. Okay, so what are catalytic promoters? Means chemicals are the elements or chemical species which enhance means increases, enhances the efficiency of catalyst. Efficiency of catalyst. Okay, the chemical species which enhances, that means increases the efficiency of catalyst, that is called as catalytic promoters. You know, so I'll say the reaction. I'll take again this one. N2 plus 3H2 gives rise to 2NH3. So students, here iron is the catalyst. Of course, 700 Kelvin temperature we maintain and 200 atmospheric pressure. Along with this, we are going to use molybdenum or Al2O3 or molybdenum or Al2O3. Understand, students? So here in this reaction, we can easily say this molybdenum and this Al2O3 are called as catalytic promoters. Understand? These are catalytic promoters. They didn't increase the rate of the reaction. They just increase the efficiency of iron to exhibit a catalytic property. Understand? Here in this reaction, molybdenum and Al2O3 aluminum oxide are catalytic promoters. Means they increases the efficiency of the iron. Efficiency. Understand? Next, catalytic poison is obviously they are opposite to this. So the chemical species which inhibit means decrease, inhibits the efficiency of catalyst. Efficiency of, this is called as what? Catalytic poison or catalytic inhibitor. This process is also called as inhibition. decrease. Okay, decreases the efficiency of the catalyst. So students, here as I told you, another one. So this CH, triple bond CH, alkene is there. When we use alone, platinum, hydrogenation takes place. Okay, hydrogenation takes place in presence of alone platinum. Then this platinum has more efficiency. Okay, it has high catalytic property to convert this alkene into alkane. Understand? If we use alone platinum, then it is a fast reaction. It takes place so much fast. So instead of giving this alkene, it directly gives alkane. But if we want alkene means we have to slow down the reaction. So to slow down the reaction, again the same reaction and consider. Instead, along with this platinum, if we use sulfur or arsenic, with this platinum catalyst, if we use sulfur or arsenic, okay, these two decreases the efficiency of the platinum. Okay, if efficiency decreases, then the rate also decreases. Then rate decreases, instead of giving alkene, they give alkene. Understand? This is what catalytic poison. Poison means it is negative only. Okay, we decreases the catalytic property, that is called as catalytic poison. Understand? Okay, so this is all about types of catalyst. Positive catalyst, negative catalyst, autocatalyst, catalytic promoter and catalytic poisons. These two are not catalysts, just these are the species which increases or decreases the efficiency of the catalyst. Okay, so the next we will study about catalysis. Okay, listen. So the catalyst is a chemical species which alters the rate of a reaction without undergoing any chemical change at the end. This is called as what? Catalyst. Okay, and the process is called as catalysis. It is a phenomenon. The phenomenon in which the catalyst which alters the rate of a reaction without undergoing any chemical change. That phenomenon is called as catalysis. This complete process. Understand? So in this catalysis, two types is there. I'll explain. So first one is homogeneous catalysis. Homogeneous catalysis. Another one is heterogeneous catalysis. Heterogeneous catalysis. This is homogeneous catalysis. So students, listen. I'll take example here. Then you can easily understand what is this. So example is, initially, before going to that, let's say. So example, conversion of SO2 to SO3 using NO. So students, listen. Here SO2 gas is there. Okay, it reacts with this oxygen in presence of nitrogen oxide. This is also a gas and it forms SO3 gas. Okay, another example I will give, that is CH3CO, CH3CO, CH3. Students listen. I will directly take an example, then you can easily understand. This is first example. Second I will take CH3, COO, CH3 is gas plus H2O gas, FCl, sorry, not gas, liquid, 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 CH3, COOH, liquid, and CH3OH, liquid. Understand? So another one example here, C12, H22, O11 undergoes hydrolysis in presence of H2SO4 or HCl. Okay, H2SO4, that is dilute, liquid, liquid, it is dilute H2SO4. This is also liquid, form C6H12O6 plus C6H12O6. Understand? So listen students, in all these three examples are the example for homogeneous catalysis. In that, what you are going to observe from this reaction? Gas, 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 gas. These two are the reactant, this is the catalyst, this is the product. Here, these two are the catalyst, this is the these two are the reactant, catalyst, product. Reactants, catalyst, product. So in all these three, the phases, the physical state of the reactant, catalyst as well as product is same. I am not telling it is only gas, it is only liquid, it is only solid. I am just telling if the reactant is liquid, then catalyst is also liquid, the product obtained is also liquid. If the reactants are gas, then the catalyst is also gas, then product is also gas. Then what is homogeneous catalysis means? If the reactants, products and catalyst are in the same phase, called as homogeneous catalysis. Called as homogeneous catalysis. So these are the examples, very important for 2 marks, both homogeneous as well as heterogeneous. What is homogeneous catalysis? Give an example. What is heterogeneous catalysis? Give an example. And the mass difference between homogeneous and heterogeneous catalysis. Understand? So students here, if the reactants, products and catalysts are in the same phase, gas, gas, gas means either liquid or gas. No matter whether liquid or a gas, but all the products, reactants and as well as catalysts are in the same phase. Okay? Next, heterogeneous. Very important for 2 marks. Both homogeneous and heterogeneous. This is also important for 2 marks. So students, I will give the example for this also. Listen. N2, this is a gas. 3H2, this is also a gas. Here, iron, this is solid. Next, it forms 2NH3, that is also gas. This is the first example. Okay? Next, second one, SO2, that is gas, plus O2, that is also a gas. Instead of that, if we use platinum, that is solid, gives SO3, that is also gas. Okay? Next, decomposition of ammonia, or you take vegetable oil. This is liquid. And H2. This is gas. Here, nickel is the catalyst, that is solid. Fat is the product, that is solid, semi-solid. Fat is semi-solid, or I could take it as solid. Understand? So students, from here, what you are going to observe? Here these two are gases, the product is also gas, but the catalyst is solid. Here the solid is, reactants is gas, product is also gas, and it is okay. So the catalyst used here is solid. Next, vegetable oil is liquid, hydrogen is the gas, hydrogenation of vegetable oil it is. Next, nickel is the catalyst, that is solid in state. Okay, fat is one, that is semi-solid. Understand? So from this and this, what you are going to observe? Here listen, the reactants, products and catalysts are in the same phase. Obviously, here they are in different phase. Okay? So, if the reactants, products and catalysts are in different phase, called as heterogeneous catalysis. Okay, so students, note down in this, homo means same, hetero means different. What is different, what is same here? The phases of the product, means the physical state of products, reactants and that the catalyst is same, then it is homogeneous, and here it is heterogeneous. This is the example. Understand? Homogeneous catalyst and heterogeneous catalyst. So the next one is, students, that is the absorption in catalyst. A very important thing is absorption in catalyst. How the catalytic property takes place, especially when the catalyst is solid and the absorbing species are gases. That is modern theory of absorption. Okay. So next one is absorption. Initially, I write the difference between, that is very, very important, difference between homogeneous and heterogeneous catalysis. The difference is very, very important for 2 marks. So first one is homogeneous. Okay. Another one is heterogeneous. So students, homogeneous means here, as I told you, the reactants, products and catalyst are in same phase. Next, here, the reactants, products and catalysts are in different phase. Different phase. Okay. Next, second one. They depends on. They does not depend on. Does not depends on surface area of catalyst or size of the catalyst. They doesn't depend on surface area of catalyst, but they depends on surface area of catalyst and also particle size. Particle size of reactants. Particle size of reactants. Okay. Next. Reactant molecules collide with each other. Collide with each other to form intermediates. Later forms for products. Later form products. Here, reactant molecules absorb on the surface of catalyst to form products. Means here only thing you have to say, here the collision takes place, here the absorption takes place. Remember, collide with each other, absorb. Means here collision takes place, there absorption takes place. Am I right here? Here collision takes place, here absorption takes place. And the last one is the example. Example for homogeneous catalysis is SO2 plus O2, that is gas in presence of NO gas gives SO3 gas. Here also take the same example, SO2 gas plus O2 gas, but platinum, that is solid, and SO3 gas. This is the difference between homogeneous and heterogeneous catalysis. So students, in the tomorrow's class we will discuss with how the absorption process takes place. This absorption process takes place in heterogeneous catalysis. Okay, how the mechanism takes place, what are the steps involved, and also what explains exactly the heterogeneous catalysis, and also their activity and their selectivity. Okay, thank you.